Alright, Assalamu alaikum and hello everyone. So for today's session, we're going to look at Gauss elimination method. So this is part of system of linear equation. As mentioned from our previous class, so the concept of Gauss elimination is that we're trying to make sure anything below the diagonal matrix becoming 0, meaning that anything below A21, AM1, anything in between it to become 0. Okay, so from here it will become something like this. So how are we going to ensure to get this upper triangular form? Okay, anything below the diagonal becomes 0. So we're going to use multiplication factor. Right, so let's look at one example. Okay, so BDA 34103 for section 9 and 10. And we're going to look at Gauss elimination method. Alright, so let's say you have been given system of linear equation x1 plus 2x2 equals to 1, 3x1 plus 4x2 plus 5x3 equals to 0, 6x2 plus 7x3 plus 8x4 equals to 2, and 10x3 plus 11x4 equals to 3. So first thing what you're going to do is that we're going to transfer from the linear equation to become complete matrix form. So we have 1x1 plus 2x2, 0x3 and 0x4, x1, x2, x3 and x4 equals to 1, 0, 2, 3. Right, this is the complete matrix form. And then we've got 3x1, 4x2, 5x3 and 0x4, 6x2, 7x3, 8x. Right. So we've got 0x1, 0x1, 6x2, 7x3 and 8x4, and 0x1, 0x2, 10x3 and 11x4. So next we're going to transfer the complete matrix form. We write it in augmented matrix form. So we've got 1, 3, 0, 0, 2, 4, 6, 0, 0, 5, 7, 10, and 0, 0, 8, 11. Okay, and then 1, 0, 2, 3. Okay, so this is the complete matrix form. And this is the augmented matrix form. So I've mentioned that in order for us to apply the Gauss iteration method, we need to make sure anything below the diagonal matrix becoming 0, meaning that we're going to make sure this 3 becoming 0, this 6 becoming 0, and 10 becoming 0. So in order to do this, we're going to do from row to row. So this is R1 is row 1, R2 is row 2, R3 is row 3, and R4 is row 4. So basically for Gauss seidel, we're going to start with row first, okay? Going to make sure this one becomes 0, and if let's say once we have changed R2 to become 0, then we need to change this one to become 0 if let's say we got any number here which is not 0. So we do basically row by row, and then you move to column. So basically for this example, we're going to make sure this number 3 becoming 0, and then after that, since this is already 0, this is already 0, so we're going to change this one to become 0, and then next we're going to change this to become 0. Okay, so first step is we're going to eliminate A to 1. So A to 1 is referring to this one here from R2. So in order for us to eliminate A to 1, okay, in this case the value is 3 from R2, so we need to find the multiplication factor. So I write M to 1, okay, is equals to the value here on A to 1 divided by the value of its diagonal matrix. So in this case 3 divided by number 1 here, so it becomes 3 over 1, so it is equals to 3. So since the operation is that we're going to, in order for us to eliminate A to 1 from R2, so the equation is negative M to 1 multiplied by row 1 plus row 2, then we're going to replace that on row number 2. So please take note that it must be negative M to 1. So what I always do is that I write negative M to 1 is equals to negative 3. Okay, because we have the sign negative here. This is the equation that we're going to use. So to ensure that you won't do any careless mistake, so this is how I'm going to write it. So first negative M to R1, okay, so negative M2 multiplied by row number 1, so negative, I've got negative 3 is the M2 1. Okay, so negative 3 here multiplied by 1 will get negative 3, and then negative 3 multiplied by 2 we got negative 6, and then we multiply by 0, becomes 0, then becomes 0, and then multiply by 1 here, we've got negative 3. Okay, next, negative M2R1 plus row 2. Anything on the second row we need to add the value. So negative 3 plus 3 here will become 0. The next, negative 6 here plus 4, it become negative 2, and then 0 plus 5 here, anything on the second row, yeah. So it becomes 0 plus 5 is 5, and then 0 plus 0 it becomes 0, and then negative 3 plus 0 here, it becomes negative 3. So basically what we're going to do next is that we're going to transfer everything in here into row number 2 as been stated here. Okay, so our matrix, so what will change is only on the second row. Okay, we're going to change the second row, so our matrix will become 1 2 0 0. Okay, that is for the first row. Then I'll write the third row first, 0 6 7 8 0 0 10 11, and then going to transfer this equation on row 2, so it becomes 0 negative 2 5 0. Okay, and then here we've got 1 2 3, and then the value here is negative 3. So this one is from here. Okay, so now this is our first row, second row, third row, and fourth row. So we have already transformed 3 here, now it has become 0 here. So as I mentioned, we need to do row by row, since for the third row is already 0 and the fourth row is already 0. So what we need to eliminate? We need to eliminate number 6 here, because let's say this is our diagonal matrix. So next would be the value of 6 there. So next, eliminate. Okay, now if you can see that the value of 6 there is on row number 3, so we're going to eliminate. Okay, the way we write it in matrix, if we're referring to the value of 6, is A, row number 3 and column number 2 from row 3. So same approach. Okay, first we need to find the multiplication factor for this one in order to make sure it becomes 0. So what we're going to do is we're going to divide the value of 6 here with its diagonal. So the value of diagonal is negative 2. So M32 is equals to A32 divided by A22. Okay, 22 is the diagonal here. So 6 divided by negative 2 is equals to negative 3. Okay, so negative M32 is equals to positive 3, and the equation is negative M32 multiplied by R2, then we're going to plus row 3, then we're going to transfer it into row number 3. So let's calculate negative M32 R2 first. Okay, so 3 multiplied by 0 becomes 0. 3 multiplied by negative 2, it becomes negative 6. 3 multiplied by 5 becoming 15. And this one is 0. and then 3 multiplied by negative 3 becomes negative 9. So that is M32R2. Next, negative M32R2 plus R3. So 0 plus 0 becomes 0, negative 6 plus 6 becomes 0, 15 plus 7 becomes 22, and 0 plus 8 becoming 8, negative 9 plus 2 become negative 7. Okay, so this is the value that we're going to transfer in row number 3. So our matrix will become 1, 2, 0, 0, then 0, negative 2, 5, 0. Okay, remember that what will change is on row number 3. So we'll write row number 4 first. 0, 0, 10, 11. Okay, and then the value here is 1, negative 3, 3 here. So what will change is the value on row number 3, where we will get it from here. So it becomes 0, 0, 22, and 8. The value here is negative 7. So now this has become our row 1, row 2, row 3, and row 4. Alright, take note that from 6 here, okay, it has already changed to 0 by using the multiplication factor. So guess what's next that we need to change? Okay, let's draw the diagonal first. Okay, so the last one is to transfer the value 10 here to become 0. So step 3 is eliminate A, row number 4, column number 3, from, it is located on row number 4. So M, multiplication of M for 3 is equals to A for 3 divided by its diagonal, which is this one. It becomes A3, 3. And the value is 10 over 22. 10 over 22 is 0.4545. Okay, next, negative M for 3. Why negative? Because the equation that we're going to use is negative M for 3 multiplied by the row itself. So it becomes negative 0.4545. Right, and then equation going to use is M for 3 multiplied by row number 3 plus row number 4. We're going to transfer it to row number 4. So let's do it step by step. Negative M for 3, row 3. Okay, so the value for negative M for 3, row 3 is, so we're going to multiply everything in here with the multiplication factor. So it becomes 0. Negative times 0 is 0. So this one will become negative 10. And negative 0.4545 multiplied by 8 becomes negative 3.636. Negative 7 times negative 0.4545, 3.1815. So negative M43 R3 plus row number 4. So we're going to add the value here with row number 4. Then we're going to transfer the value in row number 4. So 0 plus 0 will become 0, 0 plus 0 becomes 0, negative 10 plus 10 becomes 0, negative 3.626 plus 11 get 7.364, and then 3.1815 plus 3 we'll get 6.1815. So this is what we're going to transfer in row number 4, all of this value here. So our matrix now will become 1, 2, 0, 0, 0, negative 2, 5, 0, 0, 0, 22, 8, okay, and then 1, 3, negative 7. Okay, so for row number 4, we'll take the value from here, everything from here. So 0, 0, 0, 7.364. This one will become 6.1815. So now this is our row 1, row 2, row 3, and row 4. So if you check here that we have already got the upper triangular form, whereby anything below the diagonal has become 0. Okay, so from here we can use backward substitution, because we know that backward substitution means we're going to solve it from here. So from here basically we know that 7.364 x4, okay, because this value is basically on x4, is equals to 6.1815. So x4 is equals to 0.8394. Okay, now we have already got the value of x4. Then going to change to this row now. Okay, same. So this one is 22x3 plus 8x4 is equals to negative 7. So 22x3 plus 8x4 equals to negative 7. So 22x3 plus 8, because we already got the value of x4, which is 0.8394, equals to negative 7. So x3 is equals to negative 7.8394 times 8, negative 7 divided by 22. So x3 is equals to negative 0.6234. Okay, let's check the value here, whether we got it correctly or not. Okay, so 0.8395 x4, x3 is negative 0.6235. Okay, we are there, we have already defined x3. So now we're going to move on the second row now. So from the second row, we know that negative 2x2 plus 5x3 is equals to negative 3. So negative 2x2 plus 5x3 is equals to negative 3. So negative 2x2 plus 5, we know already the value of x3, which is negative 0.6234 is equals to negative 3. So x2 is equals to negative 0.0585. So by now we have already obtained the value of x2. So we're going to move to row number 1. So this is what we call as backward. So from R4 you move to R3, from R3 you move to R2, and from R2 you move to R1. So 1 x1, okay. So basically, simplify things. So from here we know that it is x1 plus 2x2 is equals to 1. So x1 plus 2x2 is equals to 1. So x1 plus 2, we already obtained the value of x2, negative 0.0585 is equals to 1. So x1 is equals to 1.1171. So I track back the answer, negative 0.0588 and 1.1176. So we have already obtained the value of x1, x2, x3 and x4 by using backward substitution, by using Gauss iteration method. So that's all for Gauss iteration method. Hope to see you again on our next session. Thank you very much.